Firstly, convert 165 kilometers to nautical miles. To do this, the answer is 89 nautical miles. Now we need to substitute into the departure formula. In minutes, multiplied by the cosine of the latitude. Which of these do you know? Equation. The latitude is 60 north. Its cosine is a half. .78 minutes of change of longitude. This is 2 degrees and 58 minutes from an initial So, since we are going eastwards, it is 5 degrees 22 minutes west minus 2 degrees 002 degrees 24 minutes west. The new position is 60 north. Here is another example of a different substitution. In this one, you are given the departure and have to find of 44 degrees and 11 minutes, equivalent to a departure of 2,000 nautical miles. Equals the change of longitude in minutes multiplied by the cosine of the latitude. Which of these do you know? Write them in. We now need to convert 44 degrees and 11 minutes into minutes. Now rearrange the equation to make the cosine of the latitude the subject. Use the arc the latitude of 41 degrees. So the latitude is 41 degrees. Remember, it could be of the equator. You need to be able to solve questions where you are given departure at one An aircraft leaves position G at latitude 40 south and flies the following runway. Track 180 true, distance 240 nautical miles. H 240 nautical miles. J to K, track 000 true, what is the rumline bearing and distance from K to G? There are two ways you can basic departure formula. It works, but it's slower. The other is by use of the following formula. Departure at latitude B equals cosine A over cosine B. By using a double substitution into the basic departure formula, and then secondly, by using the new method. Let's look at the double substitution method first. We can't directly find the departure. We don't know the change of longitude. However, if we can find the change of longitude between H as the change of longitude between K and G. We need the departure and the latitude between H. But we first need to find the latitude of H. 240 nautical degrees. It's simply 240 divided by 60. So H method will now be to find the change of longitude from H to J from the departure. This Once we know the change of longitude from K to G, we can find the departure at 40 south. Departure equals the change of longitude in minutes multiplied by the cosine of the latitude. Is 44 south. And the departure is 240 nautical miles. And solve to get the change of longitude from H to J as 300 and departure between K and G. They're the same two meridians. Now we're able to solve the departure is 40 south, and the change of longitude is 333.6 minutes. And the rumline bearing is obviously 270. It's a parallel of latitude. Using the new formula, we start with the same diagram. The formula is departure B equals cosine A over cosine B. Let's rearrange it to the subject of the equation. Choose latitude B to be the one for which you already know the departure. This means that you can solve for latitude A, which is 40 south, without any further rearrangement of the formula. A equals departure at latitude B times cosine A over cosine B. Nautical miles. Cosine A is the cosine of 40 degrees. Multiply that out on a calculator, and the answer comes to 255.6 nautical miles. But a lot quicker to work out. Don't forget that for there will always be 4 optional answers given, and it may be possible to solve the question by elimination of the impossible. An aircraft at position 27 north and 170 degrees west then 3,000 kilometers on a track of 090 true. True. Then 3,000 kilometers on a track of 270 options are A. 27 north, 170 west, B. 27 north, 173 degrees 18 minutes west, or D. Now there are three ways you could approach this question. You could calculate every step, or you might see that the numbers chosen you might see at a glance that only one answer can possibly be right. Tick the correct box There was a numerical shortcut which would have saved time. The clue came with the information that the leg distance You should remember that the circumference of the Earth is 40,000 kilometers, and that 10,000 kilometers so 3,000 kilometers will be 3/10 of 90 degrees, which is 27 degrees distance for a purpose. It was to place part of the calculation at the equator to keep it simple. Often requires you to draw on work from earlier parts of the course. However, to visualize what is going on and instantly eliminate the impossible answers. We start in the Northern Hemisphere. We don't need to work out the exact latitude, it's just further south and therefore nearer the equator. If we fly the same ground distance east and west, the change of longitude when flying eastwards at the lower latitude. Therefore, the aircraft will finish up at the same latitude. A is the start position, eliminate it. B is on the equator. Start position, not west, eliminate it. That's a lot quicker than all that calculation. You need to be able to see the big picture. A diagram, even a rough one, nearly always helps. The basic departure formula is departure equals the change of longitude in minutes multiplied will be asked in such a simple form. So, expect unit conversions and departure at one latitude and asked to find it at another, you can do it by double substitution, but always is required in this form. If you use it in this form, remember to choose latitude. This means that you can solve for latitude A without any further rearrangement of the formula. There will always be 4 optional answers given, and it may be possible to solve the question by elimination. If ever in doubt as to how to start, write down the departure equation and substitute in what you know. Remember that a diagram, even if it's only a sketch, usually helps.